Hi everyone, welcome back. So in our last couple of lessons, we've talked a lot about ions and ionic bonds and mostly focused on binary compounds. So today I want to build off of that and go into our last topic that we'll go about in this unit regarding ionic bonds. And so we're going to talk today about polyatomic ions. So I hope you guys didn't think that everything ionic was going to be as simple as our binary compounds. We have one more thing to go through here. So let's take a look at polyatomic ions today. So polyatomic ions, okay, are ions that consist of more than one atom. So the other ions we talked about, things such as sodium ion or fluoride ion and chloride ion, oxide ion, right? Those are single element ions. Polyatomic ions consist of more than one atom, so they carry a charge as an entire group. Even though they're more than one element or are made of more than one element, they carry a charge as one entity, one group. And so we treat them as though they are one single compound together, okay, a single unit. So a few examples are hydroxide ion, okay, which is the elements oxygen and hydrogen, and we consider those together, they have a net 1- charge. Carbonate ion is actually made of 4 atoms, a carbon ion and, atom and 3 oxygen atoms, okay, and combined, those have a net 2- charge. And ammonia is the only positively charged ion that we'll talk about, is 1 nitrogen atom and 4 hydrogen atoms, and together they have a net charge of 1+. So just a couple examples there. We have a big list that we'll be taking a look at here. So even though we have a big list, you do not need to memorize these polyatomic ions for this class, okay? At the beginning of the school year, I gave you guys a polyatomic ion sheet. So you should have that. It's on the back side of the periodic table that I provided to you guys. In our lessons, as you go through this, I've also linked that sheet and made it available to you again now. So do not lose it if you have it, or if you did lose it, fortunately I made it available to you. Print it out. You're going to want to use that and keep that and make that available for things moving forward. So here's a few of the polyatomic ions. The sheet I gave you looks a little bit different than this. We noticed that the majority of the polyatomic ions have a 1- charge. Okay, there's quite a few of them here. Okay, we also have a group of 2- charge, 3- charge, and our 1 lone ammonium ion with a positive charge. So how do we write the formulas using polyatomic ions? We talked about the crisscross method with binary compounds. It's the same thing using polyatomic ions. So if we take a look at magnesium ion and sulfate ion, okay, if we wrote those out, you can look up sulfate ion from your polyatomic ion sheet. Okay, we already know magnesium has a 2+ charge, so we can put the 2+ charge with that. And the sulfate ion, we want to write the entire ion formula and then include that charge for that polyatomic ion, which in this case, sulfate is SO4 and has a net 2- charge. So then we still use the crisscross method. So we move the 2 from magnesium down to the subscript for sulfate, and the 2 for the sulfate ion down to magnesium. Now there's a few other things that we need to make sure we pay attention to. We write this out as magnesium sulfate. In this case, instead of having 2 of those, we know this cancels out and can be put in the lowest ratio 1-to-1 for this particular polyatomic ion, but they're not all going to be that easy, of course, right? So if you have more than one polyatomic ion, okay, if you have more than one, you must use parentheses and then a subscript outside that parentheses. So we just looked at sulfate. If I had multiple sulfate ions in our compound, okay, in our salt that we have, we actually put the parentheses around the polyatomic ion. If there's a subscript that's part of that polyatomic ion, that goes inside those parentheses. So this 4 right here under oxygen goes with or inside that parentheses. And then the number of those ions is the subscript outside the parentheses. So in this case, if we had 3 sulfate ions, we want to make sure we have a 3 subscript outside that. This tells us that because we have 3 of these ions, we have 3 sulfurs, and we actually have 12 oxygens. So let's take a look at this. So calcium and hydroxide. We'll write our symbols along with their charges. We know calcium has a 2+ charge, and from our cheat sheet, we have hydroxide with a 1- charge. Okay, you'll see hydroxide a lot. You probably won't need the sheet for it here as we move forward before we get too far in. So calcium 2+, it goes down next to the hydroxide ion, and the 1 for hydroxide goes over with calcium. When we write this out, let's take a look. Okay, calcium hydroxide is not CaOH2, right? We have to have those parentheses. Okay, so we put the parentheses around the hydroxide and then the 2 outside of that. Okay, so do those parentheses matter? They absolutely do. Let's take a look at what happens if we don't use the parentheses compared to when we do properly use those. Okay, so calcium hydroxide, as we just looked at, with the parentheses and the 2 subscript outside the hydroxide ion. Okay, this means that we have 1 calcium atom, 2 oxygen atoms, okay, because we distribute that subscript that's outside the parentheses to each of the atoms inside the parentheses. So 2 times 1, we can pretend there's a 1 subscript next to that oxygen because there's only 1. But remember, we don't always have to write 1 as our subscripts and superscripts, right? So we have 2 oxygens, and then same thing with hydrogen, we have 2 hydrogens. Let's take a look at what happens if we didn't use those parentheses. So calcium and OH2, okay, we have a total of 1 calcium, a total of 1 oxygen atom, and a total of 2 hydrogen atoms. Are these the same? No, there's a difference in the number of oxygens simply based on how the formula was written. Okay, these are not the same compound. So how do we name these compounds? Okay, we follow the same rules as we did with monoatomic ions, okay, and our binary compounds that we looked at. The cation always comes first. Okay, the cation always comes first in the name, and it's the name of the ion minus the word ion. Okay, so typically that's the element name. Okay, it's the element name. Now we will have one example where if ammonium ion is the cation, okay, so that might happen, then that would come first in the name. Okay, and then the anion comes second in the name. Okay, and we just use the name of the anion. Okay, spelling counts. We're going to take a look at some of these polyatomic ions that have a difference in 1 letter. Okay, but they are definitely different compounds. So use your polyatomic cheat sheet in order to look these up and make sure you get the spelling right and the charges and formulas right for all those polyatomic ions. Okay, so KBr is potassium bromide. We know that. We did that when we were looking at binary compounds. Okay, aluminum chloride. Okay, and here we have magnesium, and if we look on our cheat sheet, NO3 is nitrate. Even though there's a 2 subscript out there, that's fine. We still name it the same. It's just magnesium nitrate. And then potassium permanganate. Okay, so it's going to take a little bit of practice taking a look at that sheet of polyatomic ions in order to recognize what part of that compound is part of the polyatomic ions. So make sure that you're looking that over and getting familiar with recognizing these polyatomic ions. Okay, so writing some formulas. What I want you to do is I want you to write down these 4 compounds, the name of these 4 compounds, and then I want you to write out the formula for these. So what I'm going to do is I'm going to go to the next slide where I'll have a cheat sheet that you can use, similar to the one that you have printed out available to you. Okay, and then I want you to write these formulas. So when I go to the next page, pause the video, and then we'll come back and go over those. All right, now that you've written down the formulas for those, let's take a look at what you have here. So calcium sulfate is the first one we looked at. Okay, in this case, our first ion is the calcium ion. We should already be familiar with that one, is Ca. And sulfate, okay, has the same net charge as that calcium ion, so we have the same number of each of those ions. Sodium hydroxide, okay, Na has a 1 plus charge and hydroxide has a 1 minus charge, so we have 1 ion for each of those, 1 sodium ion and 1 hydroxide ion. Okay, beryllium acetate. Okay, beryllium we know has a 2 plus charge, and then acetate, okay, has a 1 minus charge. Okay, so don't forget to use those parentheses. Okay, I don't want to see you not using those parentheses, and then we have the incorrect number of calcium and hydrogen and oxygen atoms in that compound. Okay, if you're not sure, okay, if we back up and take a look at sodium hydroxide, if you put the parentheses around the hydroxide polyatomic ion, even if you don't use a subscript outside, I will not count that wrong. So just know that moving forward. Ammonium sulfate, here's that case where we have the cation first being the polyatomic ion. Okay, so here we have ammonium ion written first. In this case, we have 2 of them. So that 2 goes outside the parentheses for that. And sulfate, okay, ammonium sulfate. This one is made of 2 polyatomic ions. So, all right, so how are the names related? So a few things that we're going to want to know, and maybe you've already seen this on the sheet of polyatomic ions. If you see the word bi in a polyatomic ion, that means there is a hydrogen that's part of that polyatomic ion. So bi means hydrogen. Make sure to remember that one. Put a star next to this, that way you know, because sometimes the names change solely by having bi added to it, meaning there is a hydrogen added to that polyatomic ion. So if it has the suffix ate, okay, that's the most common ion of that base element. So sulfate, SO4 2 minus, is the sulfate ion. Okay, it can also have the suffix ite. What that means is it has 1 oxygen different from that most common polyatomic ion. Okay, so in this case, sulfite has 1 less oxygen than sulfate. Okay, however, they have the same charge, if you notice. Okay, our next one, NO3 1 minus, that is the nitrate ion. And then 1 less oxygen is going to change that suffix again, just 1 letter in the name and spelling of that polyatomic ion in nitrite. Okay, and then our last one, ClO3, is chlorate, and 1 less oxygen is chlorite. Okay. If it has per as the prefix and then ate as the suffix, that means there is 1 more oxygen than 8, or the most common. Okay. Hypo as the prefix with ite means there are 2 less. Remember, ite is less, okay, and hypo is extra. There's an extra 1 that's less than that. Okay, so make sure to go over these. You'll probably want to remember these as we're looking at this. You may see something like this on the test. So get comfortable using these polyatomic ions. I want you to get some good practice with this. See me if you have some questions, or message me anything that you need some help with on these. The key with doing these binary compounds as well as the polyatomic ions is make sure you practice. Okay, use those worksheets, do the practice, and see me if you have any questions. Okay, so I hope this video has been helpful for you guys. If you have any questions, you know what to do. We'll talk to you in the next one. Have a great one.